What if I told you there are lakes at the bottom of the ocean? Not puddles, not illusions, actual lakes with clear edges, with shorelines, with something that looks exactly like a surface, a line you can swim up to, hover above, and then cross. Divers have seen them. They descend through the open ocean, expecting nothing but darkness and pressure, and suddenly they're staring at what looks like a shoreline. The seafloor dips, and below it sits a pool of liquid, calm, heavy, and separate. When currents pass over it, the surface ripples. When something falls in, it disappears like it just sank into a lake. But this is happening thousands of feet underwater. There is no land, there is no air, there is no sky. And yet, there is a lake. Even stranger, these underwater lakes have waves. They have boundaries so sharp you can trace them with your hand. Some even look reflective, like a mirror laid across the ocean floor. And here's the part that makes scientists nervous. If a fish crosses the wrong boundary, it doesn't struggle. It doesn't escape. It dies, instantly, as if it crossed into an invisible trap. Around some of these lakes, the ocean floor is littered with perfectly preserved bodies of animals that made one wrong move and never came back out. Whatever this liquid is, it doesn't behave like normal water. It doesn't mix, it doesn't spread. It just sits there, contained by nothing you can see. For decades, people refused to believe these places were real. They sound impossible. They feel wrong. They go against everything we think we know about how water works. But they exist. They've been filmed, sampled, studied, and according to physics, they are completely allowed. But what you're actually seeing is far stranger than a normal lake. The idea that breaks your brain. When you hear the word lake, your brain instantly builds a picture. A bowl of land holding water in place. A surface touching air. Something separate from the world around it. That image is so deeply wired into us that the idea of a lake underwater feels impossible before we even think about it. A lake, by definition, is supposed to be exposed to the sky. That's the first assumption that breaks. We believe lakes need land boundaries, but land is only one way to contain liquid. Physics doesn't care about shorelines or maps. It only cares about forces, pressure, and balance. If something can keep a liquid from spreading, it doesn't matter whether that barrier is rock, glass, or something invisible. The second assumption is air. We think a lake must have a surface that touches the atmosphere. That surface feels essential because it's how we interact with water every day. But a surface is not defined by air. A surface is simply a boundary between two substances that don't easily mix. That boundary can exist underwater just as easily as it does above it. Freshwater is the third mental trap. Most people imagine lakes as clean, drinkable water separated from salty oceans. So when someone hears underwater lake, their mind jumps to the impossible idea of fresh water somehow surviving at the bottom of the sea. That misunderstanding alone fuels most of the myths surrounding these places. This is where the illusion takes over. These formations look like lakes because they behave like lakes. They have edges, they have surfaces, they even have motion across those surfaces. But they are not behaving like water we're used to. They're following a different set of rules, ones we rarely notice because they usually stay hidden. The truth is, water does not automatically mix just because it touches more water. Mixing requires energy, and when two liquids have very different densities or salinity levels, that energy barrier becomes surprisingly hard to cross. Under the right conditions, separation becomes more stable than mixing. To understand why these underwater lakes exist, we have to let go of how water looks in everyday life and start thinking about how it behaves when physics is in control. To understand why these exist, we need to unlearn how we think water works. Density. To understand how an underwater lake can even exist, you have to understand one invisible force that quietly controls almost everything happening in the ocean. Density. It's not dramatic. You can't see it directly, but without density, the ocean would behave in ways that feel completely alien to us. Most people confuse density with weight, but they are not the same thing. Density is about how tightly packed molecules are inside a substance. A small object can be very dense, and a large object can be less dense. What matters is how much mass is squeezed into a given volume. This is why a massive steel ship can float while a small pebble sinks instantly. You've already seen density at work, even if you never thought about it. Pour oil into a glass of water and it floats on top, forming a clear, unmoving layer. Shake it and the layers briefly mix, but the moment you stop, they separate again. Not because they want to, but because physics forces them to. The less dense liquid rises and the denser one sinks. Now imagine pouring thick syrup into juice. The syrup sinks, spreads slowly, and stays at the bottom. That's density again. The syrup's molecules are packed closer together, making it heavier per unit of volume. Water behaves the same way when you change what's dissolved inside it. In the ocean, salt is the key ingredient. When salt dissolves in water, it increases the mass without increasing the volume very much. That means salty water becomes denser than fresh water. Add enough salt, and the difference becomes extreme. Some underwater brines are several times denser than normal seawater. At that point, the water stops behaving like normal water. It becomes heavy enough to sink and stay sunk, even when surrounded by other water. That dense brine settles into depressions on the seafloor and stays there, just like syrup at the bottom of a glass. There is no wall holding it in place. Density itself becomes the barrier. You might wonder why the surrounding seawater doesn't simply mix into it over time. The answer is energy. Mixing two liquids with very different densities requires constant motion, turbulence, or heat. In the deep ocean, conditions are cold, calm, and stable. There isn't enough energy to force the layers together. Depth makes this even more powerful. Pressure increases with every meter downward, locking these layers into place. Once separated, the system becomes stable. Disturb it, and it may blur for a moment, but physics will always push it back toward separation. Imagine pouring glass into water. It sinks and stays. Underwater lakes exist for the same reason. Not because something magical is happening, but because density is doing exactly what it always does, even in places that feel impossible. Brine pools. On the ocean floor, in places where sunlight never reaches and pressure is crushing, there are pools of liquid that look like lakes but behave like traps. These are known as brine pools, and they are some of the strangest environments ever discovered on Earth. They are not rare accidents. They are stable, long-lasting features of the deep sea, quietly existing far below the surface. A brine pool is a body of extremely salty water sitting on the seafloor, separated from the surrounding ocean by density alone. The salinity can be 5 to 10 times higher than normal seawater, making the liquid so dense that it flows like syrup instead of water. This density is what allows it to form a distinct pool with sharp edges, almost like a shoreline carved into the deep ocean. These pools have been found in several parts of the world, but the most famous examples are in the Gulf of Mexico, the Red Sea, and parts of the Mediterranean. In each of these regions, the geology beneath the seafloor plays a crucial role. Thick layers of ancient salt lie buried underground, remnants of oceans that evaporated millions of years ago. When seawater seeps down through cracks in the seafloor and reaches these salt deposits, it begins dissolving them. The more salt the water absorbs, the denser it becomes. Eventually, the brine is too heavy to rise back up. Instead, it sinks and spreads along the bottom, collecting in low points and forming a pool that can last for thousands of years. What makes brine pools so unsettling is how normal they look at first glance. Submersibles and remotely operated vehicles have captured footage of what appears to be a calm lake sitting inside the ocean. There is a visible boundary between the brine and the seawater above it, so sharp it looks like a surface you could stand on. When currents pass overhead, the brine ripples. It even forms waves. In some locations, the boundary is so reflective that it looks like a mirror laid across the seafloor. Light bends as it passes through the density change, creating a shimmering effect that makes it hard to tell where the ocean ends and the brine begins. For pilots of deep-sea vehicles, it can feel like hovering over an alien landscape, but beauty is deceptive. These pools are deadly. Most brine pools contain little to no oxygen, making them instantly lethal to animals that rely on oxygenated water. On top of that, many are loaded with toxic chemicals like methane and hydrogen sulfide, substances that disrupt basic cellular processes in most marine life. Fish that accidentally swim into a brine pool don't thrash or struggle for long. They become disoriented, slow down, and then stop moving entirely. Their bodies sink into the brine and remain there, preserved by the extreme salinity and lack of oxygen. Over time, these pools accumulate remains, forming what scientists often describe as underwater graveyards. Some brine pools are surrounded by rings of dead animals, creating a clear line between life and death on the seafloor. Crabs, eels, and fish gather near the edges, drawn by bacteria and chemical reactions happening at the boundary. But one wrong movement can be fatal. It's a razor-thin margin between survival and instant death. What makes this even more disturbing is how still everything looks. Because the brine doesn't mix easily with seawater, bodies don't decompose the way they normally would. The scene can look frozen in time, as if the ocean itself paused. To human eyes, it feels unnatural, like something that shouldn't be allowed to exist. For a long time, scientists assumed nothing could live inside these pools. They were considered biological dead zones, useful for studying chemistry, but irrelevant to life. That assumption turned out to be wrong. At the very edges of these toxic lakes, and even within them, life found a way. Microorganisms were discovered thriving in conditions that would kill almost everything else. These microbes don't rely on oxygen. Instead, they use chemical energy from methane and sulfur compounds, forming the base of a completely different kind of ecosystem. What looks like a lake of death is, for some life forms, home. This discovery changed how scientists think about life on Earth and beyond it. If organisms can evolve to survive in poison, darkness, and crushing pressure, then environments once thought impossible suddenly become plausible. Brine pools are no longer just geological oddities, they are living laboratories. And this is where the story takes an unexpected turn. Because in these lakes that seem designed to kill, some life didn't just survive here, it evolved to depend on it. Life that shouldn't survive. For a long time, brine pools were thought to be the end of the line for life. Too salty, too toxic, too hostile. But when scientists finally sampled these environments in detail, they found something completely unexpected. Life wasn't absent, it was just different. Hidden in the dense brine and along its edges were organisms that didn't follow the rules most life depends on. These organisms are called extremophiles, a broad term for life that thrives in conditions most organisms would find lethal. In brine pools, many of these extremophiles are microbes so small they're invisible to the naked eye, yet powerful enough to build entire ecosystems from chemical reactions alone. What makes them truly alien to our intuition is how they survive. They don't breathe oxygen. Instead, they use chemicals like methane, sulfur compounds, or hydrogen sulfide as their energy source. This process, known as chemosynthesis, allows life to exist without sunlight or oxygen, relying purely on chemistry to survive and grow. In these environments, microbes form thick mats along the boundary between brine and seawater, where chemical gradients are strongest. That thin line becomes a factory of energy, supporting not only microbes but also specialized animals that feed on them. Entire food webs form around reactions that would be poisonous elsewhere. Scientists care deeply about these organisms because they may be living clues to Earth's distant past. Early Earth had little oxygen, intense chemical activity, and extreme conditions that resemble modern brine pools far more than today's surface environment. Studying these microbes helps researchers understand how life may have begun before oxygen reshaped the planet. These ecosystems also expand our understanding of where life can exist. By proving that life does not require sunlight, fresh water, or even oxygen, extremophiles force scientists to rethink the basic limits of biology. Environments once dismissed as sterile are now seen as potentially life-supporting. The most unsettling part is how familiar this pattern is. Chemical energy, simple cells, extreme environments. Strip away plants, animals, and oxygen, and what remains looks eerily like the earliest chapters of life on Earth. These microbes are not just survivors. They are specialists shaped by millions of years of evolution to exploit conditions that kill everything else. In doing so, they offer a glimpse into a time when life was simpler, tougher, and far less forgiving. These organisms may resemble the first life that ever existed. We started this journey with a simple question. What if there are lakes at the bottom of the ocean? At first, it felt impossible. Lakes need land. Lakes need air. Lakes are supposed to be something we can touch and see in the daylight. Yet, deep beneath the waves, these so-called lakes exist. They ripple, they shimmer, they even have edges that look like shorelines. And still, they defy our intuition. The reason they feel impossible is the same reason they are so fascinating. Our brains are wired for everyday experiences, pouring water, swimming in lakes, watching rivers flow. We assume all water should behave the same way, but physics doesn't follow assumptions. Density, pressure, salinity, and chemistry come together to create these stable, separated layers of liquid. No magic, no laws broken, just natural forces acting in ways our intuition struggles to grasp. Nature doesn't need walls, air, or magic to produce something extraordinary. It only needs the right conditions. The ocean simply obeys the rules of physics, and when we look closely, it surprises us. From deadly brine pools that host unique life, to haloclines in caves that bend light like liquid mirrors, these underwater lakes reveal a reality that feels impossible because it is outside our daily experience. Reality doesn't need to be magical to be mind-blowing. The ocean and the rules it quietly follows are enough to astonish anyone willing to look. The world isn't stranger than we imagine, it's stranger than we're prepared to understand.